All right, in these videos, I'm going to go over the Unit 1 test, so that if you want to go back and retake any learning objectives from Unit 1, you have this video to kind of help you remember what was going on and hopefully figure out what the problems were asking. All right, so Unit 1 was all about limits. All right, so you're going to see a lot of this limit notation. Again, the thing to remember with the limit notation is our x value is getting close to 1. So what happens as our x values get close to 1, our y values get close to blank. All right, so you're basically filling that blank. As your x values get close to 1, what are your y values getting close to? And the thing to remember with limits is you don't care about exactly at 1. So if we're looking at this graph, I don't care about exactly what happens at 1. So I can kind of ignore this line of exactly at 1. But if I'm near 1, kind of around this green line, you see all my y values in this general area, and they're all getting close to -1. So the answer for this one, the limit is -1, because that's what the value that our function should be at that point. Right. F of 1, if I actually plug in 1, I would get this dot there at 2. That's what the actual value is, but everywhere around 1, it looks like our value should be -1. All right, for number 2, all right, we know the limit as x approaches 7 is 6. Again, our x values are getting close to 7. So as we look at these tables, we're looking for the x values to get close to 7. A is going to be out because all these x values are close to 6. B looks good because 6.99 and 7.01 are really close to 7. C is just like A, so that's out. And then D, again, 6.99 and 7.1 are both close to 7. So these two are our options between B and D. So those are the x values getting close to 7 part. And now we need our y values, our outputs, to get close to 6. All right, in B, 7.006 and 6.995, that's about 7. And the bottom, 5.998 and 5.999 is 6. So D is going to be the right answer because our x values, the top row, is getting close to 7. Our y values, the bottom row, are getting close to 6, which is exactly what we want. Our x values are getting close to 7. Our y values are getting close to 6. And then 3 is basically just what I've been saying the whole time. All right, what is the statement? Limit as x approaches 4 of f of x equals 7. So our x values are approaching 4. They're getting close to 4. And our function values are getting close to 7. All right, so B is the right answer for that one. And the 3 reasons why a limit won't exist. We have jumps. For our function, looks like that. We have a jump between it when the two one-sided limits don't agree. We have asymptotes, which is basically just like an infinite jump. It's going to infinity, something like that. And then we have oscillation, which I never know if I'm spelling right, but basically this is where we have this graph that hits basically every value in a small area rather than just a single value. All right, so those are our ways that a limit won't exist. All right, so that's our first learning objective, which is all about just kind of what does this limit notation mean. All right, our next learning objective has to do with estimating limits from graphs. All right, so remember these little negative signs here and here mean you're just on the left side of that value, so you don't care about the whole limit, you just care about the left side, and the other ones are the full values. All right, so which of these ones does not exist for this graph? Well, the limit of 1 from the left, we're just looking at the left-hand side of 1, so we're kind of looking at this part of our graph, and all those are going to 0. So that exists. At 1, we're looking at both sides of the graph, so we also have to consider the right side of 1, but both of those are, again, going to 0. So this is 0, this is 0. 3 from the left, I only care about the left-hand side of 3, which is right there. That's going to be 2. The full limit at 3, on one side of 3 we have this, the other side of 3 we have this asymptote, so this one should not exist. And 5, again 5, all the values around 5 are here at about, let's call it like 4.8. All right, so you can see the only one that does not exist is the full limit at 3 because of that asymptote. All right, the left-hand one does because it's just this piece there, but the full limit doesn't because we have an asymptote there. And the last learning objective, asymptotes are when your limit will not exist. All right, for 6, we have kind of 3 different things we have to decide if they're true or not. So the first thing, the left-hand limit at 2 is equal to g of 2. Well, g of 2 is the exact value at 2, which is just that dot there. All right, so g of 2 is -1. The left-hand limit at 2, we look just to the left of 2, and we're in this area there, and it's also going to give us -1. So 1 is right. All right, 2, the left hand and the right hand limit at 6 are equal. So if we're at 6, just to the left of 6, we're in this area, and that looks like it's going to be -1. Just to the right of 6, we're right here, and that also looks like we're going down towards -1. So these two are equal. And then the last one, the limit at 6 equals g of 6. Again, g of 6 is the exact value, is this dot down there. But the limit, if we just look around 6, is, well, we actually just saw it just above. If the two one-sided limits agree, then that's our full limit. The function value is -3, and those are not equal. So that one's wrong, which means 1 and 2 are correct. And for 7, we want to find what values of a, so as x is close to what numbers are my limits going to be 0. So remember, we know the y value in this case, so I'm kind of looking here. All right, that's where my y values are 0, and we're saying, are there places where our limit equals that? At 0 here, you have a one-sided limit, but there's a jump, so the limit doesn't exist at 0, so those are going to be out. Right. At 1, the limit's actually down there, not up there, that's just the function value, so 1 would be out. At 2, we kind of cross through here, and everywhere around 2, our values are near 0, so this is actually going to be one of our answers. And at 4, the only difference between 2 and 4 is the open circle. But again, we don't care about exactly what happens at 4. Everywhere around 4, we're still near that red line, so 4 also works. So B is our right answer. All right, 8, we're kind of just making these limits. All right, so we need the limit of as x approaches 2 to be 1. So as 2, 1 is about there. 3 not to exist, and 5 to be 2. So 5, 2 is about there. All right, so ways we can make limits exist. We can just kind of have just like a hole there. All right, so that's fine. That'll make the limit as x approaches 2 equal to 1. To make a limit not exist, we know our different ways from our previous learning objective: oscillation, jumps, and asymptotes. So I'll just put a jump at 3, have it go there, and then jump up to there. And then again at 5, as long as our line kind of goes through that dot, it's fine. And also, you don't need to have open circles for the 2 and the 5. These could be closed circles as well. All right, but open circles kind of show us where we were aiming for, and then kind of just connect them. All right, so this is our second learning objective on this test. All right. Estimating limits from graphs. So again, just remember, you're not looking directly at that value, you're looking around that value. All right, our third learning objective on the Unit 1 test is estimating limits from tables. So again, just keep in mind a limit. Your x values are getting close to a number. Your y value should also be getting close to a number. So if we look at this first table, if we look along the top row, right, kind of the middle is where you're looking, because in the middle, they're getting close to 4. In the bottom row, you're seeing are those also in the same place getting close to a number. On the left-hand side, we have these numbers that are starting with a 5, they're getting closer and closer to 6. On the right-hand side, although it starts with a 6, 6.99 is not close to 6, it's close to 7. Right, so although our x values are getting close to 4, one side of this table is getting close to 6, the other side is getting close to 7, which is going to make C the right answer, because on the left, we get 6, on the right, we get 7. All right, and the full limit's not going to exist because these two one sides don't agree. 10, again, we're just looking for the same type of thing. What is our x values getting close to, and then what are the y values getting close to? So again, we're kind of looking in the middle here because they're coming from two directions to meet in the middle at 2. In the bottom, all those numbers in the middle are getting close to -1. So our limit, our x is approaching 2, and our limit is actually a number -1. All right, so B is going to be our answer. Okay, and again, for this one, the exact same thing. The middle, those numbers are getting close to 3. And on the left-hand side, these numbers are getting really big. They're getting really big. Oh, except for they're negative, so they're going down. On the right-hand side, they're going up. But the important thing is no, they're definitely not 0. They're definitely not both 3. They're definitely not both 10. But since they're going kind of opposite directions, all right, we're going to get our limit does not exist, because really these are kind of telling you they're asymptotes, but the big thing is there's a big jump from -8,000 to 8,000. So we have this huge jump, means our limit is not going to exist. And here we have to create a table of values. So again, we're kind of see what was happening in the previous questions. Again, so we want our values to get close to 1. So right in the middle, I want those numbers to be close to 1. I'll just do 3. As our numbers that are close to 1, well, 0.99 is really close to 1 on the underside, and then 1.001 is really close to 1 on the other side. And then I can just make these numbers slightly bigger and farther away from 1, slightly smaller and farther away from 1. All right, so now I have my x values in the right place. And then on the left side of 1, so over here, I want those values to get close to 5. So I can put, say, 4.99. That's pretty close to 5. And then maybe just make those numbers a little bit farther away from 5. So as I'm getting closer to the middle where x is 1, my y values are getting close to 5. On the right-hand side, now I want those to get close to 8. So over here, I just do the same thing. 7.99 is close to 8. And just make those numbers slowly get farther away. So as my numbers get closer to 1, my y values get closer to 8. All right, so this fits the thing. The left-hand side of 1, they're all close to 5. The right-hand side of 1, they're all close to 8. All right, so that's our third learning objective, is using tables to evaluate limits.